Hi बच्चे, today we are discussing on the chapter of light of class 10th. We will discuss about a small part of this chapter, that is the image formation of concave mirror and also convex mirror. See, the surface of a concave mirror or convex mirror is a part of a spherical mirror. So always a sphere has a radius, so also the concave mirror and the convex mirror has a radius that is equal to the spherical mirror. See, my palm, this side of palm is lying now concave surface. Okay, when we are flipping our palm, then the upper side is like a convex surface. The spherical side is outward, and for concave mirror it is spherical surface is like inward. See, M dash is a concave mirror. Why this is concave? See, this side is the reflective surface and that is inward. So M dash is a concave mirror and it is the part of the whole circular mirror whose center is C. Here C is the center of the circular mirror and also the center of M dash concave mirror. And X dash CX is the principal axis of the M dash concave mirror. See, this side is the inner side is the reflective surface. M dash is the convex mirror and this side is the reflective surface of the convex mirror. This is the whole circular surface. X dash is the principal axis. C is the center of the circular surface and also the convex mirror. And CM or CP is equal to the radius of the convex mirror. P is the pole, C is the center. When the outer surface acts as reflective surface, it is called convex mirror, like this surface. This upper part is the reflective surface. This is the convex mirror. This is a convex mirror. This side is the reflective surface of the convex mirror. The central part, that means this point, is called the pole P. P is the pole of this convex mirror. And here already we have seen that this is the principal axis X dash C X, and this is the principal of the axis of the M dash convex mirror. See, this is a concave mirror M dash. The mirror is a part of a circular mirror and the center of the circle is the center of this circle is the center of the concave mirror. Principal focus. When parallel rays to the principal axis after reflection meets at a point or looks like coming out from that point, the point is on the principal axis and the point is called principal focus. The distance between the pole P and the point F is called focal length, and F equal to R by 2. We can prove that in another session. We can prove this. See, this is a concave mirror. PC is the line, is the principal axis of this mirror. The parallel rays are coming by this way, and after reflection on the mirror, these are going out by this way. all the parallel lines after reflection meeting at the point F. F is called focus point. PF is the focal length of this mirror. So, where the parallel lines meet, that is called the focus point, and from the pole to the point F is called focal length of the mirror. There is a convex mirror. This side is reflective surface. This is the principal axis, and all the rays coming from the infinity after reflection, the rays are going like this on this path. This is coming in, this is coming out rays, and they are not meeting. So how the image will form? When we imagine that the rays is extend to another side of the convex mirror, they will meet at a point on the principal axis. The point is inside the convex mirror, and the point is on the principal axis. So the point is there will be form an image, and this is the point is called focal focus, and from this point to the pole is the distance called focal length of this convex mirror. So for the convex mirror, the point is imaginative or virtual, and for concave mirror there is actually the rays is meeting on a point that is real. So here most of the cases the image will real. On another hand, for the convex lens, the image will form inside the mirror, and that is virtual. See, I have written looking like the rays are coming out from F, from here. But actually here the point is meeting at this point. We will discuss about the image formation for the mirror. So we have to know how image is formed. There will be a source point from the on the object. From that source point there will be originated two rays from the same point, and when the two rays again meet after the reflection of the surface, then it will make a image. See, there has been originated two rays, and one ray is coming through center. So this ray is after reflection is going again to the same path, and the parallel rays is going through F and going out through F, like this path, meeting at this point. So the image will be formed here. So source should be from the source of the two rays will be same. Here see a picture of a girl. The source point is O, and two rays is coming out, and at I they are meeting after reflection. So at I there will be the image. So minimum two rays is required to make a point, image point. When a ray is coming through the C, it will go back through the same straight line path. On the other hand, the parallel rays are coming always coming out through F, and when a ray is coming through F, it will parallel to the principal axis. These are the three rules. The first case is object is at infinity. When object is at infinity, the rays coming from the object are parallel rays to the principal axis. See here the parallel rays are coming and meeting at the focus point. So image will form at F. Always the parallel rays after reflection going through F. So the rays are meeting at F. The image is formed at F, and the rays are meeting in front of the mirror. So the image will real and under the principal axis. So the image will inverted and diminished. Why diminished? The magnification formula m equal to v by u. V is the image distance from the pole, that is fp, and the object distance is where object is placed to the pole. So here object is placed at infinity, so the denominator is very much larger and the image distance is fp. So the magnification factor will be very much diminished. When object is placed beyond center, see this is the center and this is the object is placed small distance from C, the image will form between C and F. See, the two rays is coming, one is parallel and one is coming through C and meeting at the point between C and F, and the image will be real because it is formed in front of the mirror. It is inverted because it is forming under the principal axis, and smaller because see the image distance is between C and F to the pole is smaller, that is numerator, and the object distance is beyond C to the pole, that is larger. So m is smaller. When object is placed at center, see two ray I have drawn. One ray is parallel which will go through F, and one is coming through F. After reflection it will parallel. So when it is meeting, that is at C. So when object is at center C, the image will form on the center. So image is formed at C. The image is forming in front of mirror, so this is real, and under the principal axis, so it will be inverted. And see the image distance and object distance is equal. So image object between C and F. See, this is the object, two rays. This is the rays. This is the rays. After reflection, this ray will going through F, and after reflection, this ray will going through C and meeting beyond C. The image will real, inverted and magnified much larger because this is the V and this is the U. When object is placed at focus, then see two rays is coming out from the object. One is going through C and then is parallel to principal axis. It will go through F. Two rays going out, that will be parallel, so they will make an image at infinity, inverted and real. and see m equal to v by u. The image is formed at infinity, so v is very larger than u. So the image will very much larger than the object. This image nature is actually opposite to the image nature when we place the object at infinity. When the object was at infinity, the image formed at f and very much diminished, and when we are placing the object at f, the image will be at infinity and very much magnified. Truly, this is opposite to the first case. Object placed between focus and pole. See, from the object, one rays after reflection going through C and another rays that is parallel to the principal axis is going through F, and two rays are not parallel, they will not meet each other. So if we extend the rays another side to the another side of the mirror, they will meet, then there will be an image formed inside the mirror. See, the image will be larger to the object, larger than the object. It is inside the mirror, so it is virtual, and it is formed on the principal axis, so it is erect, and it is larger because see, v equal to p and the image distance, and u equal to lesser than fp, so v is greater than u. By the convex mirror, there is two cases. See here, when object is at infinity, the rays are coming parallel rays, and after reflection they will meet inside the mirror in the principal axis, that is the focus point of the convex mirror. It is inside the mirror, so the image nature will be virtual, and the object distance from the pole is infinity, and the image distance is pf, so v is very less than to u, so m will be highly diminished and it will be erect. When object is placed between infinity and pole, say one ray is coming parallel to principal axis and another is coming, which will go through C, and the parallel rays will go through F. They are meeting at the point between pole and F, making a image A dash B dash, and it is erect. It is made inside the convex mirror, so that is virtual and also diminished as v is less than u. So image nature is virtual, diminished and erect. See, these two cases are exactly opposite. The object is at infinity, image is formed at f, and it is diminished, highly diminished, and see, the image will form at infinity, object is at f, and v is at infinity, so m will be infinitely large, highly diminished, infinitely large. is the object is at infinity, image will be at f. Second case is object is beyond C and image will between C and F. See, the image is gradually going towards this side. After that, object at C and image at C. Then the object is between C and F and the image is beyond C. Object is at F, the image is at infinity. This is exactly opposite to this. Last case is the object is between F and P. So, and this is the unique case. The image will be virtual and this side. So, practice all the cases again and again. Then you can remember the things